Problem number 4. Did you get -3? Yeah, so you can see this is a standard linear, solving a linear equation in algebra. This is sort of problems that you'll see. Another topic is inequalities. A lot of times the way that they indicate the solution here, we would just say -3. They might list -3, but if they're looking for a solution set, you should really put it in squiggly brackets like that. Because later on we're going to have like infinite numbers of values, and we want to have a kind of a similar way to present it. Solve an inequality. Now remember that the only difference between equations and inequalities is that whenever you multiply or divide, is in the process of doing the steps, whenever you multiply or divide by a negative number, the sign has to switch. We'll start off with number 28. There was an answer that looked like this. And that means this. So if you want to just flip it around so that the x is on the left-hand side and the 8 is on the right-hand side, then just make sure your inequality symbol is pointing at the x. So this is what you would have from here to here. One person had -x greater than or equal to -8. That's also correct work up to this point. When you multiply by -1, the negatives in both places change from negatives to positive, and then the inequality symbol changes as well. All right, so less than or equal to 8 would be the solution on this one. Let's do 32. All right, let me help you with the first step. You could work through this whole problem in fractions, which I wouldn't recommend because it becomes messy. What I'm going to do is multiply by 6. If I multiply u over 2 by 6, the 6 cancels the 2, leaving a 3. So I have 3u. If I multiply the 6 by 2/3, the 6 cancels the 3, leaving a 2. 2 times 2 is 4. Now I'm multiplying by 6. I'm not multiplying by a negative, so the sign doesn't switch. So the sign is going to remain the same, less than. Then I'm going to multiply the 6 by u over 3. 6 cancels with the 3, leaving a 2. So 2u. And finally, if you have 2 and you multiply that by 6, you get 12. Okay, so the original problem is very messy because of the fractions. But if you multiply all of those 4 terms in that inequality by 6, the 6 will cancel out all the denominators. This is a way that we get rid of all the messy fractions. Fractions are hard, so let's get rid of them as our first step. You can see it's a fairly nice, easy equation. You put the 2 over here and you get u, and then you put 4 over here and get 16. Add 4 to both sides. U is less than 16 would be the answer on that one. The way that our author represents answers is with intervals a lot. And a lot of times it'll just say use interval notation. If you see something there, as you look down at this column right here, there's a lower bound and an upper bound. And there's a square bracket here and a square bracket over here. The square brackets correspond to the less than or equal to sign. The equal to sign is there. When you see an open parenthesis, like next to this B here, that means that B is not included. And so next to the B, you're going to have a strictly less than sign rather than a less than or equal to. So everywhere you see the square brackets, you're going to have the equal to inequality symbol. And this just represents all numbers between A and B, including A, but not B. This one here would be all numbers between A and B, including B, but not A, and so on. Down here, all numbers from -infinity up to A. And another way we write that is x is less than A. They also have the graph here. And one of the things that is unusual about our author here is they use the little square brackets or the open parentheses on a number line, as opposed to what you might be used to, which is the dots and the open circles. You remember doing that? Other textbooks do it that way. 3 different intervals to identify the same set of numbers. The solution that we came up when we solved one of those problems on the other page, you might recall, was this. And the answer we came up with was x is less than or equal to 8. That is one of the representations. It's this one right here. Well, less than. It's this one right here. The a value that they're using as a variable here is 8 in our example. So the graph then would be, you take the same sign at 8, and you're going to put a square bracket. X is less than 8, so you're going to shade all the way over here. Now you may recall from what you've done in the past, this would be 9 and this would be 7 if you want to add more numbers to the number line. In other textbooks, a lot of times what they'll do is they'll put like a solid dot. But just so you know, these two mean the same thing. It's a way to represent an infinite number of numbers on a number line. You can't list them all, so we have to come up with some other way. We use inequalities, we use interval notation, and we use graphs. 3 different ways to represent the same set of numbers. All right, which leads us to some confusion, because if you had something like AB here, when we're in the Cartesian graphing, AB is an ordered pair, and you plot 1 point on the Cartesian plane. But you need to know the context. In this context, we're representing an interval. As you can see, some of these exercises will be very, very quick, because all you have to do here is just write the same set of numbers from -3 to 5, but you have to use inequality symbols. It says write the interval, so this is interval notation, as an inequality or double inequality. This is what they mean. Here's an inequality, and these up here are double inequalities because they have double inequality symbols. We usually reserve the double inequalities for a set of numbers that are between this. All numbers between this and that. Okay, do 7 through 12. I'll do the first one. X is a number between 5 and -3. We do not include -3, but we do include 5. So here's all they want for that one, this inequality. For one like number 12, this goes from the number 9 up to positive infinity. So from 9 to infinity. So for all numbers that are greater than 9, x is greater than 9. And as before, since you have a square bracket there, you want the greater than or equal to sign. All right, now we're going to go the other way. We're going to start with the inequality, and we're going to work back and write the answer in interval notation. All right, so for this one, the x is in the middle, and that's where we like it, but we need to get rid of the -4. So we have to divide everything by -4. Instead of being just 2 sides that we're dividing by -4, a compound inequality like this has 3 parts. So we're going to divide all 3 parts by -4. A negative divided by a negative is positive. -8 divided by -4 is positive 2. And 12 divided by -4 is positive divided by a negative is -3. The -4s will cancel out here, leaving x. Now, because we multiplied by a negative number, all the signs have to switch from what they were to the opposite. So this less than becomes a greater than, and this less than or equal to becomes a greater than or equal to. All right, so this is not quite yet in the form we want it, because in a compound inequality like this, we always want the smaller number to be on the left and the bigger number to be on the right. So I'm going to rotate this and put the -3 on the left and the 2 on the right. And then just make sure that if you look at the sign between the x and the 2, the inequality symbol is pointing at the x. And in the inequality involving the 3 and the x, the inequality symbol is pointing at the -3. So that's what we wanted to do here. And bring along the equal sign. Now that we have the lower on the left and the upper number on the right, we're ready to convert to interval notation. The less than or equal to sign here gives us a square bracket. And the less than gives us an open parenthesis. And all you have to do then is to put the two boundary numbers, -3 and 2, inside. And there's your solution. All right, so they really hit interval notation in all the different forms pretty hard in this section. And so you can see that we're doing a lot of linear equation solving as well. So prerequisite of this course. But it's always good to get some additional practice. And for this one, it says solve and graph. Now, when you solve it, it doesn't say whether you need to put the answer in the inequality notation or if you need to put the answer in the interval notation, so you can choose. But it does say graph. So the next thing that we're going to do is we're going to draw the graph of the solution set as well. All right. Let's take a look at number 35, just because I don't know if you recognize this formula. This is the Fahrenheit. It's the formula for degrees Fahrenheit. And so what they're saying is that it's kind of like a problem. If the Fahrenheit temperature is between -4 and 68, what would the Celsius temperature be? All right, so let's solve this one, and then we're going to do the graph. All right, the goal is to isolate the C in the middle. Put C in the middle. So to do that, we're going to subtract 32. That gets rid of that 32, but we have to do it to all three sides. Subtracting 32 does not trigger a sign change, so we're just going to bring down the inequality symbols without flipping them. It's very important to keep your operations straight. Here we're adding 32, so to undo 32, adding of 32, we're going to subtract 32. -4 minus 32, -36. Subtract over here, +36. And then that gives us the 9/5. Now to undo the times, this is C times 9/5. So to undo that and get a 1 there, so we have 1C, you can multiply everything by 5/9. You're not going to be able to avoid fractions completely in some of these problems. Now, when we divide by 5/9, you can see both the 5s and the 9s cancel out, so you just get C in the middle. And we multiplied by a positive number, so that doesn't trigger a sign change. I'm just going to bring down the signs. What's also nice about this one is that the 36 cancels with the 9, leaving a 4. So 4 times 5 is 20. And over on this side, similarly, the 9 cancels with the 36, leaving, well, it's a negative divided by a positive, so it would be a -4. So it would be -20. So if you recognize the context and you realize that this was Celsius temperature, what we would say is that a Fahrenheit temperature between -4 and 68 corresponds with a Celsius temperature between -20 and 20. All right, and here's the interval notation. They didn't ask for that, but we'll give it anyway. Here's the answer, here's the answer, and here's the answer. And remember, our author is not going to use the solid dots. Our author is going to use the square brackets. And here's the answer. So 3 different ways to represent the answer here. One with an inequality, one with an interval, and one with a graph. And for this one, they said they want the graph. Solve it and then graph it. Okay, let's go to the next chunk of problems. These are back to equations, but these are formulas. And the idea is to convert the formula as given into a new formula. So one of the things we do a lot of is something like problem number 38, where you see something y equals mx plus b. That's the equation of a line. And you may be interested in just solving that equation for one of the other variables in the equation. So all we have are x and y. Y is by itself here. So you can say that this equation has been solved for y. But what we want to do is we want to solve for x. And what that means is that we want x by itself on the left and everything else on the right. So here's our example. I'm going to rewrite the original problem, and we want to solve for x. So when we're down here, we're going to have x equals everything else. So we want to transform an equation. We want it to be the same equation relating x and y, but instead of having y on the left-hand side by itself, we want to get x instead by itself on one side. All right, so we're going to end up doing the same sorts of equation manipulations that we've done in the past. So I want to get rid of this 8, this plus 8. So to undo it, we do minus 8. And whatever we do to the one side of the equation, we have to do to the other side of the equation. All right, so that essentially gets rid of the 8 on the left. And let me bring down everything that remains. Now, y minus 8, y is not a number, so there's no way to combine y and 8 together in any meaningful way. And so we just write it as an expression, y minus 8. And again, the goal is to find x by itself. I'm not very happy with the fractions there. So my next step is I'm going to multiply by 3. And I'm going to multiply both sides by 3. Now, the nice thing about multiplying by 3 is that this 3 will cancel with this one. And essentially, when you multiply by 3, you get rid of the fractions, which makes the problem a heck of a lot easier to solve. So once you cancel out these 3's, the only terms left are the -2 and the x. No fractions. And over here on the left, the distributive property, 3 times y, and then remember to multiply the 3 by the 8 as well. Again, remember our goal. Our goal is to get x by itself. So to get x by itself, this expression means -2 times x. So to undo the times -2, we got to divide by -2. And we're going to divide every term by -2. Whatever we do to one side, we have to do to the other side. We divided the right-hand side by -2 so that the -2's would cancel and we would get x by itself. And that's what our eventual goal was. The way that I'm going to write this one is I'm going to put the number pieces together, 3 over 2, it's 1 1/2, 3 halves, but it's a positive divided by a negative, so it's a -3 halves, and then you've got the y. You can write that in different, you can write it as 3y over -2 if you want. And then the number pieces here, -24 divided by -2, a negative divided by a negative is positive, 24 divided by 2 is 12. Here is almost the final answer. If we put the x on this side, and then we take all this and put it on the other side, here's what they're looking for. Something like this, or some equivalent version of that.